Hi, my name is Ben and welcome to my AI project. So while we watch this demo of the entire project, I'd just like to explain a brief timeline of my project. At first I focused on mainly completing the labs for each week before implementing them into my own project. So this resulted in some backwards development. So I started with the GoApp AI, followed by Boids, then went to Behavior Tree AI, then to FSM AI and steering mechanics, and then finally the sensors for the AI. So when I started my project, I was very overambitious, thinking I could implement multiple complex AIs, not realising how much would be needed to actually create them. However, after a conversation with Carlo, the scope of my project was reduced to focus on AI for cars, which was my main focus. Before beginning my project, I first created a basic white box scene, which would form the basis for the movement of the AI, creating buildings such as obstacles. This was then followed by finding the assets to replace the white boxing, and assets which would become my various AI agents. This phase actually took longer than I had originally planned, due to the previously mentioned overambition resulting in a scene change to better suit the new project plan. This extra time spent on redoing of the scene added pressure onto me, as it resulted in delayed development of my AI agents. However, in the end, it did not pose too much of a worry. From this experience, however, I have learned to manage my ambition by planning out what would be needed to achieve my ideas to ensure I stay within scope. This will also help ensure I stay on track and that certain goals do not exceed their planned time frame, which would give me extra time to complete other goals. Okay, so onto the agents. The first agent I implemented was the agents from the Crowds lab using AI steering. This code was completed within week 7's lab, whereby the agents use a nav mesh to navigate a scene going from waypoint to waypoint, and a police car which will chase the racer around the scene. This was my start point for my project, as my racer agent needed to navigate the scene continuously. This gave me a good start to my scene, implementing my first two agents. In addition to this week, I also completed the Boids week 8 labs and implemented them into my scene in the form of birds flying around in groups in the sky. The implementation of these agents gave me a feeling of progress, which helped me motivate myself to continue working on the project. However, I also felt confused on my next steps, as I was unsure about whether or not to focus on GoApp or implement other AI techniques such as behavior trees and finite state machines. In the end, I decided to add other techniques which will all be demonstrated within the video. However, if I could go back, I would spend more time developing the GoApp agents, combining GoApp with an finite state machine, which would switch states based upon the current waypoint the racer was at. In regards to the Boids, I would also go back and implement an FSM, whereby the birds would switch from an idle to flee state depending on how close they were to a car or helicopter. Next, I implemented A-Star Pathfinding AI. I used Sebastian League's pathfinding tutorial and labs to do this. Within the scene, a car will follow a calculated path to a designated waypoint. If this waypoint is moved, a new path is calculated. Nodes are used to create walkable and non-walkable areas, which the pathfinding then uses to calculate the quickest path. Steering is also used to ensure the car does not cut corners and follows the road markings. The implementation of this agent was satisfying due to the length of time taken to implement it, and the end result being a clean and efficient agent. However, at a certain point, if the car is too close to reaching the waypoint, if the waypoint is then moved, a new path will not be calculated. If I had more time, I would have liked to implement a system whereby once the agent reaches the waypoint, a new destination is set, or the waypoint will continuously move around, generating a new path for the car to find and follow. On to behavior trees. For the implementation of behavior trees, I followed the KiwiCoders video tutorial on how to create a custom behavior tree editor and nodes for use in AI. Within the project, a car uses the behavior tree to at first wait for a countdown of 3 seconds and then move to a designated node around the city. Within the graph view, there is the start node, the root node, a sequencer node, which will then one by one execute the wait node and debug node 3 times before executing the move node. The debug nodes will output the countdown before the car begins to move. While following the videos, I became a bit stressed due to some errors that were not mentioned within the videos and seemed to work fine for the Kiwi coder. After some digging, a solution was found in a subreddit explaining there was simply a missing line of code, giving me much relief. If I could go back, I would like to implement more specific nodes such as the flee, wander and idle node depending on specific undecided factors. Moving to the finite state machines, I used the code from the labs and altered some of their states to create my own chase scene. Within the project, there is a car being followed by a helicopter. The car uses a finite state machine to switch between an idle and fleeing state. In essence, when the helicopter is within a certain distance to the car, the fleeing state is enabled, allowing the car to travel to a waypoint around the city in an attempt to escape. When the car does manage to escape, the state is switched to an idle state whereby once the car has reached its current waypoint, if it is still out of range of the helicopter, it will sit idle until back in range. If I had more time, I would go back and implement a sensors element onto the helicopter, whereby if the car was out of range of the sensors, the helicopter would perform a random search state going from waypoint to waypoint until the car was found again. Finally, moving on to AI sensors. Once again, I used the code from the labs to implement another chase scene within the project. Within the project, there is a second car being chased by a police car. On the police car, there is a sensor whereby if the chase car enters within the sensor, as seen in the video, the sensor box around the police car will turn red. A later change was added, whereby once the police car had caught up and sensed the car, both cars would stop. If I had more time, I would go back and instead of both cars stopping when sensed, I would include a state whereby the car would stop for a second before continuing and the police car would wander until sensing the car again, at which point it would once again pursue it. Just before we finish, here are some code snippets for all of the AI agents. First, we have the code for the steering. Next, we have code for the FSM agents. Then we have code for the A-star pathfinding agents. Here we have code for the behavior tree agent. Next, we have code for the agent sensors. And finally, the code for the voids. And that's it. So thank you very much for watching and goodbye.